Hi everyone, this is Abhijit Paul here. I'm a product owner and I'm looking to take this course and doing this course on AI and how it impacts product managers. This is a final assessment or final assignment for the Machine Learning Foundations for Product Managers course. This course is from Duke University. The assessment, what it mentions is that in this project, I have to build a model to predict the electrical energy output of combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. So there are the few details and data that is given as part of this. There is a test data, which is like a CCP test data, which was also provided in the form of a CSV. uh, Various ambient columns in the data are also shown. The basically in this case we have temperature, ambient pressure, relative humidity, exhaust vacuum, which are the most of the featured columns which we'll be using, and the net hourly electrical energy output, that is PE, is what we are going to try to predict actually. In this case, it was an option to do using programming method or use AutoML from Google. So I used Google's AutoML in this case for doing the training, evaluation, and testing in this case. So what I did is I imported the CCPP data set that was provided in CSV into the Google AutoML and run the model basically keeping RMSE and MAE both as the type. And once I ran that model, I could see that the evaluation was pretty close actually, uh, because the R squared that we are getting in this case is 0.952, which is pretty close to 1. Even the MAE and RMSE values are pretty much lower in that case. So MAE was 2.5 and RMSE was 3.7. So what was the approach that I've taken as like it has been this one has been optimized for RMSE, but even we can see MAE also came a very lower value, and the regression model was the preferred approach in this case. And as you can see in this four feature columns that were included for getting the electrical energy output P as the target variable, the temperature and the exhaust vacuum like the AT and V were the most impacting values actually for PE. Moving on, once we did the training and evaluation, I exported the model prediction data set to a CSV file through using BigQuery. And what I did is like I tried to do a lower bound and upper bound and create a safe limit for the predicted PE values. So I took a 5% safe zone limit, which is like 5% less is the lower bound and 5% more than the predicted value is the upper bound. And I tried to create a chart for the actual versus predicted deviation. And you can pretty well see here the whole of the range that is coming is between somewhere around 440 to 500, which is very good and accurate modeling, I can say in this case. And as you can see in the chart, it is in yellow color. And the safe zone limit is basically within the whole range that we can see. And the predicted values are pretty close to the actual values that we have. So uh, by the side of it, the model has been pretty accurate in this case. Coming to conclusion, as I've already discussed, the model evaluation output matrix indicates the model is highly accurate. As we can see, the R square is coming as 0.592, which is very close to 1. The two most impacting features were the ambient temperature and exhaust volume for the electrical energy output, that is P, which was our target variable. So you can see from this feature impedance graph that was generated from by Google AutoML. And also finally I did my actual versus predicted charting actually from the data that I got by exporting, and here also we can see that the yellow color graph that was charted, it also showcases that the data for actual versus predicted were very pretty close and the model was running pretty accurate in this case. Thank you so much. I hope you like this presentation. I appreciate your feedback and reviews.